plants is bound to release a mercury as a vapor and which settles around the power plants. Next. Now the ambient air quality, this has already been discussed with Dr. G.D. Agarwal. Now these only two guidelines has been left. The industrial area has been done away. Next. Now why do we monitor objective air quality? Because when we have to comply with the standards, the standards have been set, certain limits are there. So whether these standards, we cannot see by naked eyes, whether the pollution is there or not, what is the level of the, if the level is high, we have to identify the sources and do the remedial measures, the control measures, the control equipments to be installed. So we have to monitor the ambient air quality around the, depending on the situation, to assess the health effect and potential damage to the property, to determine the background level pollution. Suppose you are going to set up an industry, under EIA the baseline quality is to be established. What is the status before the plant is coming up and what will be the status after the plant is commissioned. That is done by the mathematical modeling. The baseline, the predicted values are superimposed on the and we have come up with what is the ultimate quality of this ambient air. So we can see and foresee the management tools. The criteria pollutant upon the location, certain pollutants are already given here. Those pollutants which are not given here, certain are asked to be monitored depending on the industry. Like in petroleum industry, you have to monitor the VOCs and the hydrocarbon also by local state pollution control boards. Now we come to the site selection. The site selection criteria is important. Quality assurance, quality control in air, quality monitoring is essential. Type of pollutant to be monitored in a city. If you are monitoring in the city, we have to look for the vehicular emissions. Because in the city, urban area, the major pollution is from the automobiles, beside the industrial locations. Next. The site should be representative of the location being assessed. It should not be unduly influenced by immediate surrounding unless the influence are specifically being measured. For example, near a busy road, a factory stack or dusty quarry, the site should not be subjected to flooding and the site's classification or situation should not be changed over time. Next. Now see, certain other requirements are also seen, whether the accessibility of the site, power requirements, safety. These are also be considered at the point of fixing the monitoring station. Certain time we also ensure how much time the LCD is available. We can monitor in the absence of the regular electric power with our generators. But use of generator has got their own limitations because they cannot work continuously for 24 hours. One has to feed them with the fuel, and fuel will also emit certain pollutants which can interfere with the local air quality. If anyway we have to do the monitoring with the help of these generators, generators should be kept downwind at least 100 meters away from the samplers. Now for any coming to sampling, suppose we want to sample any environment, we need three things. First, any suction device, vacuum device, and a metering device, which at what flow rate we are sucking the air, we are drawing the air. Ultimately, we are interested in knowing the exact quantitative volume of the air which has been sucked. And then a trapping device. It may be, suppose we are working for a particulate matter, it may be a filter. For any gaseous volume, we have to impinge or adsorb on the charcoal. If it is an organic compound, it has to be absorbed in the silica gel or organic charcoal. If it is a gas, inorganic gas, it has to be absorbed in a proper solution, which can be subjected to a quantitative analysis later stage. Next. This is one of the important facts. Where to monitor them, where to take the reading. Whether we have to take the reading on this top, this point or this point. First of all, the reading should be taken at the high level, straight. If you are taking a reading from here, you will find a higher value. If you are taking a reading from here, you will find a lower value. So one should know what is the exact flow rate of the rotometer. There are various types of rotometers available in the various machines manufactured by different manufacturers. Suppose that we have to take the reading at the widest part of the float, widest part. This is circular. You have to take the diameter, highest point. Here we have to take, this is a float, we have to take the reading at the upper float. And during in this type of float, we have to take reading in here, the widest part of the float. Next. Now the methods are prescribed in the standards are improved Western Geiger methods, ultraviolet fluorescence, Knox, Jacobs method for online laser, direct reading, chemiluminescence, PM2 and PM205 is the gravimetry method, TOEM and beta attenuation. Here TOM is wrongly printed in the gadget. This is TEOM, tapered electronically, tapered oscillating environmental monitor. Then ozone, UV photometric method, chemiluminescence and chemical methods are available. For lead, it can be done by AS, ICP, or emission EDXRF using Teflon filters. Next. CO can be used by non-dispersive analyzers. It is recommended in the board, but BIS standard says it can be monitored by number of methods. But those methods are not realistically possible. One method is a CO detector. CO detector has a limitation. It cannot work in the ambient air quality. The level present in the ambient air quality, it cannot monitor that level. Generally, ambient air quality now, CO is available less than 1 or 2 ppm. So 1 and 2 ppm is not possible to monitor with the detector tubes. And then beside if we can monitor those limits, the results are about 10 to 20% plus or minus. Like one method is CO is given in the BIS method is iodine pentoxide. If you monitor through the iodine pentoxide method, you need to have keep the sampling tube at 175 degrees centigrade in the field. So it is not, you have to carry a small oven in which you can put this tube and you can monitor you have to maintain 175 degrees centigrade, which is not possible. Then we can have gas sampling bags. Any gas sampling bag will not do. The Mylar or Siren bags, which is imported from USA by a KC company or some equivalent make, that it doesn't, they do not interfere with the pollutants. You collect with this low volume sampler in about 5 or 10 liters in a gas bag and take the bag into the laboratory and do the analysis by grammatic TCD or by converting it into a catalytic converter with FID. CO can be done. Then benzene is a gas chemical based method, continuous analyzer is available. Adsorption and desorption followed by GC. Benzopyrene is particulate phase, can be extracted by solvent extraction and quantified by SPLC GC, which can be covered later on. Arsenic and nickel by S and ICP. Next. The type of sampling we are interested in monitoring the average quality, 24 hours or 25 annual averages. For that matter, we have to take the readings specified. But certain time we are interested in episodic sampling, graph sampling, excursions. Suppose we are going to check for enforcement as an enforcement agency to industry. We want to take a graph sample. So that in a short duration it is, we call it short duration sample. In duration, the batch sampling and the baseline data is collected in 24 hours. Next. The total particulate matter, all particles suspended in air is less than 100 micrometers is called suspended particulate matter. Respirable suspended particles are called less than 10 micrometers, and fine particles that is called 2.5 micrometers. Next. As per the new notification, it measures PM10 and PM2.5. A known volume of the air is passed through initially weight glass fiber filter paper GFA of size 8 into 10 inches centimeter. We are using any normal filter paper for gravimetric methods. Suppose one want to monitor the arsenic, lead or trace metal. For metal, when you are going for a trace metal analysis, you have to monitor lead and arsenic and nickel. But if the people who are having the ICP at their end, they can monitor number of particles at a one go without any extra efforts. If suppose you want to monitor the PM10 on the filter paper, then you have to use EPM 2000 filter paper. EPM 2000 is a low matrix, low background metals are there in that filter paper. The centrifugal force acts on the dust particles to separate into two parts. Here I would emphasize, if you are monitoring the SPM rather SPM is out of question right now. When the people were monitoring SPM with the RDS, they were showing the RSPM loss. The particles collected in the filter paper as RSPM. The dust which is collected into the dust grit pot, they are adding that concentration of the dust in the grit pot present with the RSPM values. The grit plus RSPM is good, they are reporting as TSPM. That is wrong, because you cannot recover the 100% dust from the cyclone. Certain dust are stick to the cyclones, inner side of the cyclone, which we are not accounting for. So whenever you have to monitor this, you have to use the two samplers. If you are having a crunch of the funds, you monitor one by one. Below 10, there was a question. अच्छा नहीं हटा दे. Difference in initial and final weight of the filter paper and cyclone cap used in calculation to express the results. If you are using the RDS sampler, then you can report the results non-respirable fraction and respirable fraction. That is the other alternative. Next. The filter paper is to be conditioned. The filter paper should be conditioned between 20 to 25 degrees centigrade and relative humidity less than 50% for 16 hours prior to weighing. Use fresh carbons. The motor, now the two types of motors are available for the monitoring RDS. One is the with the carbon filters, and one is the brushless. When you are using the carbon brushed motors, you have to take the precaution the carbon when they have got a less than 5 millimeter length, you discard those filter carbon brushes, because otherwise they will harm your commutator and the motor will be burnt. Number one. Do not bend the filter paper before collection of the sample. Filter paper can be transported in the filter paper boxes or in a polythene bags. Next. This is PM10, sampling of the respirable dust. This is wrongly printed here. This is part 23. Involve the principal filter. Whatever dust concentration is there in grams, it has to be multiplied with 10 into 1000, will convert into milligram, and again you multiply with 1000, it will convert into micrograms. This is volume to sample in the cubic meter. The volume is to be cubic meter. Next. Here you have seen the PM 2.5 filter. By using this instrument, you can monitor PM10 or PM 2.5 by changing the impactors. So ideally, if you are monitoring the ambient air quality at the same time, ideally you should monitor both use two samplers ideally, so that have a comparison, because when you are monitoring one day PM10, other day 2.5, the weather condition, the air pollution levels may not be same. If you want to compare the results of the same day, you should use the two instruments simultaneously. This is the beta attenuation measurement. This is just to show you the principle, and this will be covered by Dr. Agrawal after the lunch perhaps. Next. This is the next, please. In the beta attenuation, we also get these filter paper circles. We can take out these circles if analyzed, and number of samples can be put together and analyzed for the chemical fraction. Next. RDS is to be installed in lot less than 1.5 meters height. Ideally, it should be at a height of 3 meters on the first, not more than the first floor of the buildings. Switch on the instrument, adjust the timer reading to required hours of sampling flow rate, adjust 5 liters or 1 liter depending on the need. First, you run the machine for at least 5 minutes. Let the motor stabilize. When the flow is stabilized, then only you set the volume of the rotometer. Otherwise, it will give the initially it gives a higher reading. When the motor stabilizes, it gives the correct value. Fill the filter impinge with the 10 ml of the adsorbing solution. Sampling for 4, 8 or 24 hours depending on the need. Next. For SO2, the standards are here. Sulfur dioxide is absorbed for air in the sodium or potassium tetramercurate. Ambient SO2 reacts with it formed to a stable dichlorosulfito-mercurate complex. The amount of SO2 then estimated by the color produced by the para-aniline. Next. The range of this method can be 5 ppm or easily measured. Next. Take about 10 ml portion of the sample, add 2 ml, the chemicals to be used, mixed in the same order. First you have to put the 2 ml sulfamic acid, 2 ml formaldehyde, 1 ml para-aniline. After 20 minutes, read the absorption in 560 nanometer in a spectrophotometer with a blank as a reference. The blank may be the same absorbing solution. The same absorbing solution should be used in which no air is drawn. Next. This is the reaction. This is already given in your printouts. Next. The equipment needed for this: a mid-cut impenger containing solution, a pump suitable to desired flow rate from 0.2 to 1 liters, a volume meter, the thermometer, manometer, and timer. This can be used, the RDS or HPS which you are using it right now, there is a gas sampling attachment. You can use the gas arrangement up to 4 gases, because ideally 2 impingers should be used for 1 gas, just to see if there is breakthrough or untrapped gases escaping. But in the ambient air quality, the concentration is very low, so you can use one impinger for each gas, one for SOx, one for NOx, one for ammonia. Next. These are the chemicals required for this analysis. This is already given in the printout. Next. Now we come to the standard, how to prepare a standard curve for the SOx. We need a standard. The 0.0123 N sodium metabisulfite is equal to 1 mic. If you exactly prepare this concentration, so how to prepare this 0.0123 N sodium metabisulfite? Because it is not a primary standard. It is it has to be standardized first against the iodine. So you take about 640 milligram slightly higher than the 640 milligram metabisulfite in 1 liter double distilled water, standardized with iodine using starch as indicator. One can find how many these too many standards are to be made by a single or 1 or 2 men staff in an industry. Then for that matter, you can use the CBS iodine available with the standard company like Ranbaxy, Merck, or Collisions. They supply the concentrated volumetric solutions. So you take out the 1 ml vial that contains 50 ml, you dilute 10 times. That will give you 0.01 N. It is always better to have a concentrated solution. If you standardize a higher concentration of this, you can already dilute it to the desired strength by using the formula N1 V1 is equal to N2 V2. Normality, suppose you want to prepare a 100 ml 0.0123 N solution. Put 0.0123 multiplied by 100 is equal to normality of the standardized solution into V. So you can find out what is the V. Next. This is the sulfur dioxide analysis by fluorescent method. The sulfur dioxide absorbs under UV light energy at 190 to 230 nanometer, freeform interferences, and come to the excited state, producing fluorescence, which is measured by PMT. This is the flow diagram. Again, this will be covered by Dr. Gawal. Next. Next. This is the improved method, Jacobson or shear method. Nitrogen oxides as nitrogen dioxide are collected by bubbling in air through a sodium hydroxide solution to a suitable solution of nitrite. The nitrite ion produced during this sampling is determined colorimetrically by reacting with the exposed absorbing solution with phosphoric acid, sulfanilamide, and N-naphthyl NEDA at 540 nanometer. Next.